Welcome back to my channel Techno Namaste. I'm Dr. A. Navnita, Assistant Professor in EC Department, Mahatma Gandhi Institute of Technology. So today I'm going to discuss an instruction, multiply instruction, which is used for performing the multiplication operation in 8086. In my previous videos I have uploaded add, subtract and division. Now I'm going to discuss of the multiply instruction. So here in this one, this multiply instruction is used in assembly level language programming for 8086 to perform multiplication operation. So whenever we go for multiplication operation to be performed by your 8086, in the programming, the syntax used for writing the multiplication instruction is nothing but mul, one operand will be used. That operand you can make use. Here we have used mul BL. That means we have used a general purpose register, 8-bit register BL. Instead of general purpose register, you can use a user data. 24H, that is nothing but 8-bit or 16-bit you can make use. Similarly, instead of your data, you can use a memory location like this. So whenever a bracket with a number is written, it represents the data present in the memory location at that address which is present inside your bracket. So if you take 56 is address, at this 56 address whatever the data is there, think the data is present 3, this 3 will be taken out. Okay, so here you can make use of memory location or a register or a data. Here I am going to take as a register content BL. So whenever this instruction MUL is taken by the CPU 8086, what it is going to do, it is going to multiply the content of your BL with the default register AL. So here default register 8-bit data what is present in the AL, that it will take and that it will multiply with the content which you have taken in the BL, and the result once you multiply 8-bit with the 8-bit, the product you are going to get it as a 16-bit. That product it is going to store in the AX register of your 8086. Think example, I have taken AL equal to 34H and BL I have taken as 52H. So theoretically we will verify, and same thing you should get in the AX register when you see in the system. Okay, so 2 into 4 how much? 8. 2 into 3 how much? 6. Normal multiplication. Once H is written means it represents a hexadecimal number. Okay, 5 into 4 how much? 20. So that 20 if you divide with the 16, what you are going to get? 16 1 is 16 and the remainder will be 4. That you can write converting, because whenever you get in hexadecimal multiplication operation or in the anything addition or subtraction, if you get more than 16, to convert into hexadecimal number you have to divide with the 16. Okay, so when you divide you got 1/4. So whatever the 1/4 is there, this is going to represent your whatever the value is. This is a quotient and this is going to be remainder, isn't it? Remainder value you are going to write here, and the quotient value you are going to give for the next as a carry for the next digit. For next digit what you have? 5 3 is 15. So a 15 in hexa 15 is equal to how much? F, isn't it? So that F we have placed here, and 1 which you got here as a carry will be taken here, quotient. So when you add, what you will get here? 8, here nothing is there, 0, 8 plus 0, 8, 6 plus 4 how much? 10. 10 in hexadecimal how much? A. So that A we have placed here. And here how much? Here F means 15. 15 plus 1 how much? 16. So again you got more than 15. So more than 15 means here 16, you divide with 16, you will get 10. That 10 you are going to place here. Okay. So whatever the result which you got, that is 16-bit 4 hexadecimal number will be present in the AX. When you see in the system, so here you see in the system using DOS box or MASM, then you have to get the result taking this input in the AX register. You have to see like this. So here in this will represent first 8-bit will represent AL and remaining 8-bit will represent AH. Okay, so here in this one, how you write the program? First load this number, whatever the number you have taken in the AL, using move instruction. Next load the number 52 into the BL. After that use this instruction mul Once you run the program, you have to see the result in the AX. So instead of 8-bit, if you go for 16-bit, instead of BL, you are going to take which one? BX. Okay, 16-bit content. So whenever the 16-bit content is taken, 8086, once it gets executed, what it will do, it will take the content of BX. That content of BX, it is going to multiply with the content of default register AX. So here now, BX is of 16-bit, AX is also 16-bit. When 16-bit multiplication is done by the 8086, product you are going to get as a 32-bit. That 32-bit product, whatever you get, the first 16-bit will be stored in the AX, remaining 16-bit will be stored in the DX. So here the AX and DX will hold the total 32-bit of product value. Okay, so instead of AL, A1, BL here, we are going to take AX value and BX value. That is of how much? 16-bit. 16-bit means 4 hex digit you have to take. Take example 2, 4, 5, 6H. This is a 4 hex digit number which is going to take 16-bit. Similarly 1, 2, 3, 4H I have taken. This is also a 16-bit number. So when we multiply, you can see that after multiplication, the result it is going to present where? It is going to present in the AX registers, first 16-bit, and next in DX register, next 16-bit. Okay, in this way you can check the result and verify theoretically and on the system practically. Okay, so here in this one, I think I have given an idea of how to do the multiplication. So if you like my video, subscribe it, like it, and place some comments and share it. Okay, thank you once again.